And welcome to another video. We are going to be starting our finance chapter. And what we're going to do is work with an introduction. I call this the introduction chapter because this is going to be more of a review, supposed to be, on decimals, fractions, and percents. And that's because they all play an important role in consumer math, and you're going to be working with percents and fractions and decimals throughout this chapter. And so I want to make sure we've got a good, solid foundation when it comes to that topic. First thing we're going to look at, and again, some of this is supposed to be review, but we're going to work on how to change a fraction to a percent. And when we're doing this, what we want to do is divide the numerator by the denominator, and then you have two options. You can multiply that answer by 100 or move the decimal over 2 places to the right. You're doing the same thing with either one, but I have students that sometimes they prefer to just always multiply by 100, and others that say, oh, I just know I have to move the decimal 2 places to the right. And then we add our percent sign. So let's start with here. We're working with 45 over 100. So you're going to take 45 divided by 100, and you would get 0.45. Now, you can take that 0.45 and multiply it by 100, or what I was saying is you move the decimal 2 places to the right, which means this would equate to 45%. 12 divided by 25. Again, divide the 12 divided by 25, and we get 0.48, move the decimal 2 places to the right, and your percent is 48%. The last one, 2 divided by 5. Again, take 2 divided by 5, and you get 0.4. Now, if you move this now, again, multiply by 100 or move it 2 places to the right, that means I got to add my 0 here. This would then equate to 40%. Now let's go the other way. We're going to change a percent to a decimal. All right, so we're actually going to go the other way. What we're going to do is now, instead of multiplying by 100, because we're going the reverse, we want to divide by 100 or move the decimal 2 places to the left. So we're going the other way. And then remove the percent sign because now we're not writing it as a percent, but we're writing this as a decimal. So in other words, 12%, again, 2 ways to do it. You can divide by 100, and that will give you the answer. Or you can say, I'm going to move my decimal, which of course is always to the right here. We're going to move it to the left 2 places, which means my decimal would be 0.12 or 12 hundredths. Try number 2. We have 34.7%. I'm moving the decimal over 2 places to the left, and that would be 3.347. Again, I'm not showing a percent sign because we're actually converting from percent back to decimal. Now this one, be careful. This is 1/5%. Well, if you take 1 divided by 5, let's write that as a decimal, that's 0.2, but it's 0.2%. Now you're going to move the decimal 2 places to the left of that, and your decimal will be 0.002. This one you had 2 steps. You had to first convert to the decimal as a percent, then convert that decimal percent right back to a decimal. Now let's try a few just different word problems where we are going to calculate percents. Here is a circle graph, and remember that a circle graph should always be 100%. Now, why do I say that? What we're doing is we're looking at different insects, and the question is, what percent are wasps? Okay, well, we're looking at what percent are wasps. Well, in that case, then what I need to do is first we want to add the total. We always have to know the total because a percent, if you kind of remember, it's the part, whatever it is we're looking at, over the whole. That's what we're doing. So we know the part, the percent of wasp. So wasp would be 75. But what is the whole? That is why we have to add all of these up, which add up to 500, part over the whole. And now I can turn that into a decimal. So take 75 divided by 500. You get 0.15. Turn that into a decimal because it's asking about what percent. Well, then that would be 15%. The next question wants to know bees. I'll write down, this was wasps. Bees, well, we know over here, bees is at 125. Again, out of the whole, which is 500. Take 125 divided by 500, that's actually a quarter of it, so 0.25 or 25%. You would say in this circle graph, right, in this chart of the 4 different insects, bees took up or accounted for 25%. Here's another one. Now this one is different. This one you're given it in terms of percents already. The graph shows the results of a student's favorite school subjects. 80 students were surveyed. Find the number of students that liked each subject best. Here's the key. We need to know the whole, right? How many people altogether were surveyed, but it told us right here, 80 students. Well, then we can just break this down. For example, science. Well, science was 25%. Well, now I'm going to write that as a decimal. Whenever we take a percent and we want to put it into an equation, then what we need to do is always turn it into a decimal. That means to do the math, I'm going to turn this into a decimal, which would make it 0.25, times how many were surveyed altogether, because basically we're saying 25% of 80. And then that gives us 20 students. In other words, it was 20 students that said that they prefer science. And then we do the next one. So English was 30%. Then we get 0.30 times 80. And again, multiply those together and we have 24 students. And then last but not least, of course, math had the most. Why wouldn't it? And we want to convert that now as a decimal times 80. Take 0.45 times 80, and we get 36. Now, you can always check, by the way. You can always check to see that we got the right answer. This should add up to 80, and it does. So we were able to calculate and break it down by student number. Now let's talk about percent change. With percent change, we're talking about if we have a percent increase or maybe we have a percent decrease, but it's a percent change over some period of time. This is your formula. If you want to find the percent change, it does not matter if it's an increase or decrease. You're using the same formula. You take the amount in the latest period, the most recent period, minus the amount in the previous period, and it's always divided by the amount in the previous period. In other words, these two amounts should always be the same. Now, let's try an example, and I'll keep that formula in our view. Estimated the world population increased from 2.6 billion in 1952 to 7.9 billion in 2022. Describe the change in world population over this 70-year period. Again, when we're talking about change, we're talking about is this a percent increase, a decrease, but it's a percent change. I'm going to go back to the formula. We want the amount in the latest period. That would be the amount from 2022. That's 7.9 minus the amount from the previous period. Well, that would be from 1952, so that's 2.6. Remember, we always divide by the amount in the previous period. In other words, these two numbers, the number on the right should always match the number in the denominator. Now just do the math. So take 7.9 minus 2.6, then divide that answer by 2.6. We should get 2.04, but that's the decimal. What is that as a percent? because it wanted to know the percent. We'll move the decimal 2 places to the right, and we're talking about a percent change of 204%. Look at the next one. During a 1-month period, see if I can slide that up just enough. It's very touchy. Okay. During a 1-month period, the price of 1 share of Walmart stock went from $99.55 to $97.13. Determine the percent change in the price of 1 share of Walmart stock during this period. Again, always start with the most recent. Well, the most recent was the second one. It went from 99 to the 97. Hence, the most recent price was the 97.13, and the past price was the 99.55, and then we divide by, again, 99.55. This part is the calculator, right? Subtract and then divide by the denominator. And what we get is a negative 0.024. Change that to a percent. That would be negative 2.4%. We don't always have to say negative. What you would do is say we had a decrease of 2.4%. Meaning, if I could write, I could just write negative 2.4%, or we would say decrease of 2.4%, which compensates for that negative, and then you don't have to show that. All depends on how the problem is asking you to answer. Now we also have percent markup and markdown. And when we're doing that, the setup looks very similar, but if you want to know what the percent markup or markdown was, you're going to take the selling price minus what the person paid for it, the dealer's cost, divided by the dealer's cost, and then of course multiply by 100 or move the decimal 2 places to the right to get your percent. Well, let's start with this example here. Holdren Hardware Store pays $48.76 for glass fireplace screens. They regularly sell for $79.88. We're going to determine 2 things. 1, the percent markup on the regular price, and then the percent markup on the sale price. Let's start with A, and we're going to use the formula. We're going to start off with the regular price, which would be the $79.88, minus what he paid, which was $48.76, and then we're going to divide that by, again, what he paid. Remember, these 2 numbers will always match up. This is just numbers that you're going to punch right into your calculator, and we get 0.6382, which means it was a 63.82% markup. But what is the markup for the dealer if he puts it on sale? That's going to be part B. Take the sale price, $69.99, minus again what he paid for it, divided by what he paid. Again, put that into your calculator. So subtract first, then divide by the denominator, and we get 0.4354. In other words, the markup, once it's been marked on sale, is a 43% marked up. So almost a 20% difference. And that's basically how you find percent markups, percent markdowns, all depending on what we're looking at. All right. Now, there are lots of other types of problems when it comes to percents. And I'm going to do 4 or do 3 and then have you try 1, just to make sure we're kind of got these key words that we're going to look for. For example, when you say is, was, are, were, that always means equal. What number or what percent? That's your X. That means we don't know yet. And if you see the word of, we're talking about multiplying, okay, product. Let's go ahead and try some of these. Now you can let me read this first. What is a 15% tip on a restaurant bill of $45.71? You could go ahead and just take this and start right there if you already can figure out what you need to do. But you could also rewrite what we're really asking is 15% of 4571 is what number? Well, when we do this, you don't have to rewrite it, but I'm just showing you how we can also look at this. Change the point, right, the 15% to 0.5. Remember, of means times. What I'm doing is I'm actually rewrote this so I can just translate this right away. 0.15 of is times. The dollars stay the same. The word is. That means equals. What number? We don't know. X. All I did was just translate this using mathematical symbols and numbers. And then from here, you're just going to multiply these two together. I'm going to take 0.15 times the 4571, and we get $6.86. This would be your tip if you were going to do a 15% tip. All right, let's just try a few more. If Nancy Johnson sells a car for $19,000 and receives a commission of $475, what percent of the sale price is the commission? Well, let's rewrite again. What are we asking? We are asking what percent of the $19,000 is 475. Again, you don't have to rewrite, but I just find it easier when I'm saying what is it we're looking for. We want to know what percent of what they sold the car for was their commission. Well, now I just read what percent. That's your X. Of is times 19,000 is 475. From there, how would you solve for X? Well, you would divide both sides by 19,000. Technically, those are money. Take 475 divided by 19,000. And you would have 0.025, but they want to know the percent, then that would be 2.5%. Example 3. If the price of a laptop computer is reduced by 35% or $341.25, what was the original price of the computer? All right, original price. I'm going to rewrite then. What am I asking? We're saying 35% of what number is 341.25. I mean, that's what we're asking. Now I'm going to translate. 35% put in terms of a decimal. Of is times. What number? We don't know. X is, and then 341.25. Now we know from here, we're going to divide by whatever's in front of the X. Take the numerator divided by that denominator, and what we're going to get is the price, because it was reduced by that, what was the original? It is $9.75. And that would be your final answer. Now, last one. Kane's Furniture Store advertised a table at 15% discount. The original price was $115, and the sale price was $100. Was the sale price consistent with the ad? Now, if you'd like to pause the video and try this on your own first, go ahead and pause. All right, and if you are ready to solve this, we're just going to go ahead and solve. What is the question we're asking? We're asking, what is 15% of 115? That's what we're asking. What is 15% of 115? Well, then I'm going to go ahead and I'm going to convert to a mathematical equation. So 0.15 times 1/15, because remember, we're of always means the times, 1725. Now that's the discount. We're not done yet here. That's the discount. So what we need to do is take the original price minus the 1725. And we get 97.75. That's the answer we got. And hence, the sale price is not consistent with the discount because, and I'll just write this here, it was, because out of $100, it was $225 higher. All right, and that concludes our finance chapter or section on percents, decimals, and fractions.